Alrighty, so I won't be taking you through the entire installation process of Ubuntu today, but I do want to show you how to download it and get a VM set up. So the first thing we're going to do is directly download Ubuntu to our Proxmox server. The direct download feature is new in Proxmox 7. As you can see, it's a couple generations old, but let's look at it anyways. I still see people from time to time that don't know about it. So we're going to download to our local file today. So if we click local and ISO images, we see this direct download from URL button. And when we click that, now we can go to ubuntu.com, click download, and we're going to download Ubuntu server. So click Get Ubuntu Server, and let's click Manual Option. We're going to download 22.04, and you'll see the download start. Just cancel that. We don't need it. Right click on Download Now, and copy link. Paste right here under URL, hit Query URL, and that'll get you the file name. Now, verify your download. We'll get you some information. We want to pay attention to this string right here and this char sum 256. So we'll copy this string and pay attention to that 256. Remember it. Hash algorithm, SHA 256. And we'll paste a checksum in here. All right, so now we can download the Ubuntu. Okay, so it looks like our download is now finished, and our checksum did validate. It says task OK. We can exit this screen out now, and we'll see our Ubuntu 22.04 image is right here. So the next step in creating our VM is to press this button, Create VM, and give it a name. Pay attention to this VM ID. It can be important later on. And if you have a multiple node system, it's right here. You can select the node. We can also select if we want to start this VM with the reboot or boot of our Proxmox server by clicking this checkbox. Now we can hit Next, and here is our opportunity to insert our VM as a CD, or our ISO, as a CD. So we can select our local drive and then select our image. You can also choose at this point not to use a CD or to use no media at all. Here, we're going to select our operating system type. Today, Ubuntu is Linux. So Linux, and the kernel version is fine. Now we can hit Next. Our system defaults are again fine for today. But if you were doing like a Windows install or something, you might need to add the TPM module. Also, graphics selection, depending on what you're doing, may be important. A lot of times, I like to use Spice for multi-monitor support or for things like USB pass-through. It can be very convenient. Firmware also can be something that you have to change from time to time depending on your image. Most of the time, I use the UEFI only feature if I'm running Proxmox, but that's a separate tutorial and video. We do have them if you're looking for something like that. Machine, again, the default is good for today. Click Next, and here's our disk setup. This will set up how our VM sees our hard drive. SCSI's fine, although you can choose IDE or SATA. If you have an SSD, you want to make sure you check this discard box. It works by enabling trim. If your operating system doesn't support trim, don't click it. Now, our storage, we can select the drive that we're going to install onto. Today I'll be using backup, and our disk size is 32 gigs. That's our default configuration, and it'll be fine for me. Also, it's a good idea to check SSD emulation down here. If you are using an SSD, it lets your operating system know that you have an SSD. CPU versions, you can select sockets or cores. Both will increase your core count. Normally, I only adjust the core unless I have a multi-socketed server. Memory, adjust your RAM amounts for your operating systems depending on how much you have available. You will need to pay close attention to this using a VM because when you start a VM, your system or your VM will take that amount of RAM from your system. It's not like a container, it won't share the RAM. Network configuration, you can change your bridges if you have other bridges configured here. Today we'll be using VMBR0, which is the default installation configuration for Proxmox. You can hit next, and this is the last opportunity to confirm any information about your VM. And we can hit finish. If we'd like our VM to start automatically, we can check this box that says start after creation. Although for this particular tutorial, we won't be doing that. So we can click finish. And our system has created a VM for us. Now, at this point, if we wanted to use it, we could hit start in our console and start the process. But I want to add a USB port. So I'm going to click add USB, and down here I have a couple of different options. I can hit select USB, vendor ID, and I could select something. I don't have a link here. Or I can do USB port pass-through and select something here as well. I'm noticing that I left the device not turned on, so I'll be right back. Okay, I've turned on the device. Now, we should see the device show up. We select the device and press add. Now, if we wanted to configure other things for our server or our VM, whatever you want to refer to it as, like QEMU pass-through, we can click options and we can actually configure the QEMU guest agent right here. Here is another opportunity if we decide we want to start the VM on boot. We can select there, press edit, and check the box. Now, let's start the VM. As I said before, I'm not going to take you through the installation process of Ubuntu. This is meant to get you started. If you need a guide on installing Ubuntu, go ahead and search our channel for it. I have one that I've created in the past. So to start the VM, we hit Start and Console, and we should see it start up. Okay, so we have our VM set up and our USB pass-through. And we've done our full Ubuntu install, and now we're back at this point. So let's start our machine if it's not already running and open our console. So we're going to log in. And then I'm going to SSH in so I can copy and paste commands. It just makes it easier than typing. Alright, so we know our IP address ends in 90. Let's establish an SSH link. And we can get rid of this for now. Alright, so now I have a list of commands from a write-up I did earlier today. Now this write-up's great, and it takes us through a lot of the process. I would like to mention, and I call it out right here, that most of this information has been harvested from a forum post here. If you'd like to read that forum post, I have made a link. It is their work after all. But with that, I've had to change some of the processes to work with Ubuntu. This was necessarily meant to work with a Pi and a Pi's configuration. And we're not going to be doing it that way. We're running an Ubuntu VM on Proxmox. So a few things are different for this installation process. So the first thing we want to do is update our repositories and install the upgrades. So let's start by doing that. Alright, so our updates have been applied. Let's move on with the next step, and that's setting up a user with the name Pi. This is more closely to represent this way a system would be configured if you were on a Raspberry Pi, and it just makes the process of using OctiPrint a little bit easier because OctiPrint was designed to be used originally on a Raspberry Pi. That's not to say that it can't be used on a Proxmox VM, and it can. That's what this tutorial is about. But when the program was written, it was designed for a Pi, and the username of Pi just makes things a little bit simpler. So with that, let's set up that. So the first thing we need to do is use the add user command to create a user of Pi. Give it a password. All right. Now we need to give the Pi user sudo rights. We again do that with the add user command. We just add sudo on the end of the command. Now we need to set up TTY for the Pi user and dial out for the Pi user. This allows the Pi user to use serial. This will allow your Pi user or OctiPrint in general at the end of this configuration process to communicate with your 3D printer. That's a must since we'll be controlling it. Now we can end the SSH session and log in with our Pi user. We'll make sure we're in the root directory. And we're going to install the dependencies for OctiPrint to use. Python 3 pip, Python 3 dev, Python 3 setup tools, Python 3 virtual environment, another set of dev tools, and build essential. And again, all of these commands can be found on the Virtualize Everything website at virtualizeeverything.com. Alright, so I'm back, and our dependencies are finished installing. Now let's create a directory for OctiPrint to live in and change to that directory. We're going to do that with the mkdir command, followed by OctiPrint with the O and P capitalized. Then we're going to chain them together with 2 amperstamps and cd to the OctiPrint folder. All right, now that we're there, let's use Python to create a virtual environment. And we're going to call that virtual environment VENV. This will help with any other like weird errors and things by separating the OctiPrint running program from the host system. Sometimes you can have odd glitches and errors depending on what's going on and what's installed on the main system. It's highly unlikely with this setup, but it happens, and it's best to use a virtual environment. Now let's activate that virtual environment. And now it's time to make sure pip is fully upgraded. Pip install pip -- upgrade. All right, and let's install OctiPrint. Pip install OctiPrint. Now this is fairly lengthy, so I'll be back in a few minutes when it's finished. All right, so it looks like OctiPrint is done installing. Now let's go ahead and run the command to activate OctiPrint, and we can go ahead and test the web environment. OctiPrint, then, or VENV, bin, OctiPrint, space, serve. Now when text stops scrolling by, it should be up and running. And we're going to do this to HTTP, not HTTPS. That's important. HTTPS isn't configured. // your IP address, and on port 5000. So another colon and 5000. All right, it looks like OctiPrint is up and running. We can leave this up for a minute. We'll have to come back to it. All right, press Ctrl+C to terminate. And let's install the script from OctiPrint that will allow us to automatically start OctiPrint. And then we're going to move that script to the systemd folder, and so it turns into a service. We're going to do that with this command here. All right. And now we just have to start the service with sudo. If you followed my tutorial, this part isn't necessary, but it's here just in case you need to verify. And there you go. OctiPrint should be up and running. All right, well, excuse the bad cinematography here. I'm really new at this, and I had a hard time getting this set up. But I'm trying to achieve a point where you can see the web interface on my laptop and also see the 3D printer move. I'm planning to move the Z so you can see that everything is indeed set up and OctiPrint is controlling the 3D printer. So we can go ahead and click the up button, and there's the Z moving. We can also move Y, and we can move X. So there you have it. There's OctiPrint controlling a 3D printer running from a Proxmox server. I hope you enjoyed tonight's video. I put a lot of effort and time into this. We have another one coming hopefully soon on doing this same project inside of a container, which will allow a lighter weight implementation of this project. Please like, share, and click the bell notification so you don't miss that presentation. As always, have a good night.